This has got to be one of my favorite sections. This is evading firewalls, intrusion detection systems, and honeypots. One of the reasons why it's my favorite sections is because all of the things the security administrator does and works so hard for, I get to show you how we get to go right by all of their efforts. So in that case, it's a very pleasing module. So let's take a closer look. All right. The basic concepts here are, when it comes to firewalls, intrusion detections, honeypots, and things like that, is knowing the classic places where they're going to place them. Okay, it's very, very simple. From a security point of view, you're going to place them anywhere where you want to detect stuff. Right? So in the DMZ, on the front side, on the back side of the firewalls, in front of servers, in front of the DMZ, in front of different network segments, okay? So that's pretty predictable in itself. So you almost expect that as a pen tester when you're going into it, okay? Not much really there to hide. Also, HIDs and HIPs, NIDs and NIPs. Host intrusion detection, host intrusion prevention, and network detection and prevention, okay? It's relatively pretty simple. First, we could look at this from the network base, because we actually got to get to our targets. Then once we get to our target, depending on what that target is, do they have some sort of additional host intrusion detection or prevention software? So once you know that piece of it defensively, well then offensively you can just predict it altogether, okay? Then we got the concepts of a port scan. From pen testers' point of view, we're obviously looking for hosts and ports and services to see what's available. Also, we want to find out what firewall rules are in place, and that's called firewalking. Well, having a defensive background in computer security for several years, I can assure you that people add tons and tons and tons of firewall rules to their firewalls, but very rarely do they review them to see what has been hit. Or I would ask you, when's the last time you've reviewed all your firewall rules to see that 80% of your rules aren't even getting hit? All right? When are you pushing that through change control to get those rules removed? Because if you've got old permit rules in your firewall, and I can firewalk and find out what they are, I can effectively find a backdoor to your network. Okay? Next, let's go on to some intrusion detection prevention style categories. We have a little mnemonic here. It's called I pass the kilobytes. Now this is a really, really cool test-taking technique because it categorizes the three major types. So let's talk about them. Integrity is the first concept that really stands on its own foot. Programs like Tripwire fit in this category, and they use basically a database of sieves, or security integrity verifiers, to detect all of the files on the system, what has integrity, and if something changes, the hash changes, and therefore you get alerted. So integrity-based systems have been around for a while, but they are very rarely implemented because there's not the most popular ones. But Tripwire has definitely paved the path with this technology, and still one of the greatest players. The next category is signature and knowledge-based systems, or we call these rule-based systems. This is where someone has to have the knowledge to actually write a signature. So the good part about this is, if the defensive person does not have the knowledge to write the signature, there is no rule set, there is no signature, there is no update to detect your malicious traffic. Okay, which is the second type. These are definitely the easiest types of intrusion detection systems to defeat, because if there is no knowledge of the exploit, there is no detection. The third category would be profile, anomaly, statistical, and behavior. Now, these are realistically different words for the same thing. Okay, the different engines have been pioneered over the years. Some people call it a profile analysis, some people call it an anomaly analysis, some people call it behavior analysis, whatever. It's realistically the same thing. And they're typically host intrusion detection systems as well, or prevention systems. This is where you put your computer in learning mode. It learns what good behavior is, and then once it knows what good behavior is, you put it in detecting mode, and anything that it doesn't recognize as good, you get an alert on. All right? So this does respond very, very well to false positives, or things that you don't have the knowledge to write the rule for. So that's your third category of systems. This is a great test-taking technique as well, because a lot of these style test questions are like, 3 of the answers are profile, anomaly, and statistical, and maybe one of the other answers is, knowledge or signature. And the test questions are often written like, which one of these is not like the other? Next, let's go into firewall architecture. It's very, very helpful to know the most common types of firewall architectures there. So the first thing is a bastion host or a hardened host, and this typically sits inside the demilitarization zone. It's a host that specifically has a reduced surface area attack and is often a relay or a jump point. So if it's done properly, nobody will be able to exploit that and use that as a pivot or a relay point. The next concept would be a screen subnet, and this is realistically close to the DMZ architecture, but it's a firewall or a multi-home firewall which basically has another subnet off to the side, and that separate subnet would be used to house some sort of architecture like a web server or a database or a proxy server or a front-end radius or something like that, a radius client. Next is the multi-home. That simply means like a custom-built machine with multiple network adapter cards, so that's easy. Then is your classic DMZ, and easy to think about that because you have your private network on the inside and you have your public network on the outside, and in between that's where you host all of your security devices. So it's kind of like an overlapping security because you don't want the people from the outside to get too far into the internal network, and you also want to control the internal network, and so I think of these overlapping boundaries, so to speak. But DMZs are definitely the most classic architecture, at least in the corporate world. Next would be packet filtering devices, which are really not intelligent at all. They simply make very simple decisions on ports and protocol, source and destination ports and protocols. Then I would go into circuit gateways. These aren't that intelligent because they don't look at application layer data. They look at everything as a session or a circuit, so you don't get any application specifics. And on these types of devices, you do want to go after the application because the circuit gateway is not going to really detect anything specific inside the application. Where the countermeasure to that would be to use application gateways or proxy servers, or this is where we get the concept of deep packet inspection. Anytime you run deep packet inspection, you can completely tear apart the packet, analyze it for malicious behavior, and then package it back up, and then of course alert or whatever you're doing with it. Proxy servers I would consider in that category. And then stateful packet inspection. This is very similar to packet filtering, but in addition to just filtering source and destination IPs and ports, it also keeps track of the TCP state of the conversation. Therefore, if something goes wrong, it can reset the connection, shun the host, send it to antivirus, quarantine it, or lock it up with network access control or something like that. All right. Next, let's go into the different types of attacks between firewalls and intrusion detection systems. Some of these are evasion-oriented techniques. You really got to watch out for intrusion detection networks because they typically use a centrally logged server. And if that server is on the public network, well, then it's subject to a denial of service attack. If I can denial of service it, I can effectively shut off logging. The next concept would be obfuscation. This is where we try to hide what we're doing by using a different character set or a different encoding scheme like ASCII or EBCDIC or UTF or some other encoding scheme. Because if you're looking for just ASCII code, if I send it in another character language, well, then you're not going to have the knowledge to detect that specific code. So you hide it by obfuscating. One important thing to remember about obfuscation, it is not symmetric encryption. Just because you can't see it or you can't read it doesn't mean that it's encrypted. Remember, encryption, we change plain text into ciphertext and then, of course, back into plain text. Another thing you can do from an attacking point of view is just create a whole bunch of false positives. Right? And hopefully the intrusion detection analyst will tune out that alert. Therefore, once they tune it out and they're no longer looking at it, you can do what you want. Right? Session splicing. when you go through a network and you have to go through a detection system, if you can splice different channels, or I don't want to say frequencies, but different channels of information, then what happens is it can't put together the combination in the two separate channels, and therefore fools the intrusion detection system. Unicode evasion, another great technique. Fragmentation, you'll see this also on firewall attacks. This is another great technique, and there's plenty of tools we can use and that we'll look at in the Kali operating system. Manipulating time to lives, this works great on firewalls as well. Also, urgent flags. This is good because it basically tells your destination system, hey, I've got really, really important stuff. Please send me to your application. And sometimes urgent traffic isn't processed by a host-based system. Therefore, you can go right up to the application and exploit the system, and the HIDS doesn't even pay attention. Or polymorphic shellcode. Poly meaning many, morphic meaning changes. So this is shellcode that changes its signature all the time to avoid detection. And there's a couple really, really good algorithms that we'll talk about when we talk about Metasploit. Also, encryption. Intrusion detection systems can't read encrypted stuff because they don't have a copy of the symmetric encryption key. So therefore, by default, or at least generically stated, they don't typically read encrypted data. Or simply flooding the actual IDS in itself or the centrally logged server. So let's move on to firewall attacks. Well, the most obvious one here is going to be spoofing your IP address. If I know what you're filtering in terms of source addresses, all I have to do is get on that permit side of that rule, and therefore, if I spoof my source address, boom, I can get right through the firewall. Kind of an outdated technique, but you'll find very few circumstances where this actually does work because source routing has been disabled for quite some time now. But if you can choose the route from the actual source in itself, you could bypass a firewall or IDS. Fragments as well over here, just like we talked about with the intrusion detection. Instead of going through a URL and using a fully qualified domain name, take out the domain piece and put in an IP address. That sometimes can fool firewalls. Plus, you have plenty of anonymous style websites that attempt to hide, the true source of the traffic, which is basically another way of saying proxying. Then you have all of these different tunneling concepts. This is definitely advanced penetration testing because I know tons of penetration testers, but not all of them can do the tunneling exploits. So this is where we do things like hiding our traffic inside of legitimate ICMP traffic, or legitimate acknowledgement traffic, or legitimate HTTP traffic. So therefore, if HTTP is allowed, well then our traffic, which is exploiting in the process, also goes right through. And then of course a classic man-in-the-middle attack. All right. So then we can switch gears to honeypots. This is another subject matter that not a lot of security professionals have experience with. This definitely sets you apart if you have expertise in low interaction or high interaction honeypots. Low interaction, there's not much you can do with them. They just for basic profiling purposes. Where high interaction honeypots, these specifically allow full exploitations of those systems. Like semantic decoy server is a great example of a high interaction, or something like Spectre is basic low interaction. Okay. Also, to become an expert here, you absolutely, without a doubt, must understand how to use Snort as a packet sniffer, 2, an intrusion detection device or rule set, and then writing your own IDS rules. Absolutely critical if you really claim to be a security engineer or analyst or any sort of pen tester. You have to know Snort. If you don't, you're not on my top 5 of people to call to exploit stuff. And then of course, Spectre is a great honeypot for you to learn and profile and get the basics of honeypots. A little bit of time, you can do these in virtual machines, great experience. So this is some of the background and the basics on exploiting systems and evading firewalls and IDSs. But if you were going to try to stop me doing this, how would you do it? Well, first piece, shut down your ports. Simply stated, limit the surface area of attack. The more information you give me, the more I'm going to have my way with your systems. It's just that simple. So you should harden your systems, reduce that surface area of attack, concentrate on not disclosing anything to me, not allowing me to change anything, not allowing me to manipulate access control or anything like that, and therefore it limits what I actually can do to your network. I've seen the largest networks compromised. People walk right through them like they own the place. And we're talking very, very large, well-funded networks, walked in, exploited in hours. Use defense in depth, right? Layers of defense. Every time you put a layer of defense in there, I have to go defeat that layer. One, I have to identify the layer. I have to dissect it, figure out how to defeat it, and then ultimately, try a variety of techniques to defeat it. So the more layers, the more defense you have, the better off you are. Also, TCP resets. Learn to quarantine traffic. If you can quarantine a handful of traffic and put it in basically a sandbox of some sort, well then all of a sudden I find myself in the timeout box, and that of course limits what I can do as a pen tester. Also, learn to detect buffer overflows or polymorphic shellcode, or what we call the classic 0x90, or even ASCII shellcode. Learn to detect that stuff, analyze your networks, profile it, and basically build your own profile of what good behavior is versus bad behavior. Make sure that you're absolutely up to date on the latest and greatest patches as quickly as possible, because if it takes you 6 months to go through the patch management process, well, that's a 6-month head start I have to break into your network. And lastly, hire me. Now, this doesn't necessarily mean hire me specifically, but hire a penetration tester to come in, evaluate your networks, your system, your host, your applications, either from a white hat, gray hat, or black hat point of view, and learn to work with people like us, because we are the whiz kids that learn how to do all of this stuff, to break into your network in advance on your term, and then explain to you how we did it, and also explain to you how you could have stopped us. So hiring someone like ourselves is a great countermeasure. A lot of people, it's out of sight, out of mind. We call this the ostrich technique, where you're literally sticking your head in the sand. Stop it. Learn to get expert opinions and advice and work with us. We'll be happy to work with you because I don't know too many pen testers that are pretty silent. Most of us have, we love to talk, if you haven't figured that out already, okay? So we'll be happy to tell you all the things about your network that you didn't already know, okay? So let's go ahead and take a look at some hands-on examples.